In order to factor a quadratic expression in generic form ax squared plus bx plus c, called a quadratic expression because the highest degree is 2, and we're going to take the example where a, the leading coefficient, is simply 1 to keep it simple. In order to factor this quadratic expression, we must first remember how to distribute a product of binomials using FOIL. FOIL is F-O-I-L, where the first term is the product of the first terms of the binomials. X times x gives us x squared. The outer term is the product of the outer terms of the binomial. X times -5 gives -5x. The inner term is the product of the inner terms of the binomials. 3 times x gives positive 3x. Finally, the last term is the product of the last terms of the binomial. 3 times -5 is -15. To finish our problem, we then combine like terms by adding the -5x term, the outer term, plus the 3x term, the inner term, to give -2x. Remember, -5 plus 3 is -2. Keep the x. So now we know how to take a product of binomials and use the distributive property to get to our quadratic expression. But if we want to go back the other way, we must know how to factor. In order to go from quadratic expression to product of binomials, we must factor our equation. So in order to do this, we have to know the pattern. What we simply become familiar with is that the first term in each binomial is going to be the variable, in this case x. The numbers are special. We have to choose those from all the integers available, and they must be factors of c, factors of the constant term c, and they must sum to equal b, where b is the coefficient of the x term. Positive 3 and -5 multiply together to give -15, and positive 3 and -5 add together to give -2. So let's take an example where we are given our quadratic expression, x squared minus x minus 12. And we are asked to factor this. Well, I know that it must equal a product of binomials. Because my leading coefficient is 1, a equals 1, I know that I have x and x, because x times x gives me x squared. My first terms multiplied together give me the first term of my quadratic. Now I need to find the factors of 12 that add to x. Oh, that's right, -1. There is an invisible coefficient of 1. Well, I can factor 12, and it's -12, into -12 and 1. I could do -6 and 2. I could do -4 and 3. I could also factor +1 and -12, +6 and -2, and +4 and -3. So I need to figure out which of these sum to -1. -12 plus 1 is -11. No good. -6 plus 2 is -4. No good. -4 plus 3 is -1. Ah, there's my -1. So I'm going to take these numbers, -4 and +3, and insert them into my quadratic. Before I'm done, I should check my work by distributing. I should check using the distributive property. Check using distribution. All right, so let's try it. First, x times x is x squared. Outer, x times 3 is positive 3x. Inner, negative 4 times x is negative 4x. Last, negative 4 times 3 is negative 12. Combine like terms, x squared minus x minus 12. I recovered my original equation, so my final answer is in fact x minus 4 times x plus 3.